We're going to look at differentiating from first principles. And we're going to do 3 examples, starting with a fairly simple one. So we've got the function y equals x squared. And we can sketch this very quickly. And here we've got the x-axis and the y-axis. And when you differentiate, you're basically trying to find the gradient at a certain point. So it's the gradient of the tangent to the curve at a given point. So the point we're going to choose here is x. So when x is x, then y is going to be equal to x squared. And when x is slightly bigger, just x plus a tiny little delta x, then at that point, y is going to be equal to x plus delta x all squared. And to find the gradient, we always do the change in y over the change in x. So we're going to write, because we're talking about small distances between the 2 points, we call it little delta y over little delta x. And then we're going to do the change in y, which is x plus delta x all squared minus x squared, divided by the change here, which is x plus delta x minus x. Alright, so now we're going to have to multiply out the brackets. This bracket is going to be equal to x squared plus 2x delta x plus delta x squared, and then we've still got the minus 2x, and down here we're going to be left with just delta x. Right, so let's look at what cancels. X squared cancels with x squared, and we can also cancel out one of the delta x's. So we've got that one and the squared, they all cancel. So we get 2x plus delta x. And at this point we're going to have to take a limit, because we want to make these 2 points as close together as they can get, which means that we're going to take a limit as x approaches 0. So x is not going to be equal to 0, because then we wouldn't be allowed to divide through by delta x just now. So it's not equal to 0, but it's the limit. So then we change it to dy by dx, and that's equal to the limit as delta x tends to 0 of delta y over delta x. And as you can see here, we've got 2x plus delta x. If delta x becomes really, really small, that means that it's not going to matter compared to 2x. So this limit is just going to be 2x. So now we've got the answer. So dy by dx is equal to 2x. Let's look at another example. So now we've got y is equal to 5x cubed. So it's a slightly harder one. And we start by writing down the formula for the gradient. So in this case, we're going to substitute x plus delta x into this formula here. So we're going to have 5x plus delta x cubed minus 5x cubed all over delta x. And now we multiply out the brackets. We get 5 times x cubed. And I'm going to use the Pascal's triangle. So we've got 1, 1, 1, 2, 1, 1, 3, 3, 1. So to do a binomial expansion of this, I use the coefficients 1, 3, 3, 1. And just change the powers. If you haven't done this yet, you can also just multiply out by writing out the 3 brackets and then doing all the different combinations. But I'm going to do it this quicker way. So we've got x cubed plus 3 x squared delta x plus 3 again x, and now delta x is the one that's squared, and then plus delta x all cubed, close bracket, minus 5x cubed, and all of that is going to be over delta x. Right, let's multiply out this bracket. 5x cubed plus 15x squared delta x plus 15x delta x squared plus 5 delta x all cubed and all over delta x. Right, what I forgot was that we need to do minus 5x cubed there. And that's a good thing, because it's going to cancel with this other 5x cubed. So we cross them out. And instead of writing this whole thing down, I'm going to divide through by delta x, because now you can see that that each term has a delta x in it. So that means that we can divide through by delta x, because delta x is not quite 0, it's just a very small change. So we are allowed to divide by it. So we get 15x squared plus 15x delta x plus 5 delta x squared. So dy dx is the limit as delta x tends to 0 of delta y by delta x. So if we think about x tending to 0, you're going to see that this term is going to be completely tiny because it's something very small squared. And this is also going to be very tiny because it's something very small compared to this, which doesn't have a delta x in it. So that's the only one that we're going to keep, 15x squared. Right, so now we differentiated this one from first principles. And you can always double check your answers by using the rule to differentiate. So if we've got 5x cubed, we're going to multiply by the power, so we get 15 in front, and we're going to put the power down by 1, so the power becomes 2. So that is right. Right, one final example. Now we've got y equals 1 over x squared, which is a bit more complicated. We start by writing down the formula. So first we're going to put x plus delta x into this, and we get 1 over x plus delta x all squared minus 1 over x squared all divided by delta x. Alright, so we've got some horrible fractions here. We've got x squared there, and we've got x plus delta x all squared. I think what I'm going to do is I'm going to multiply top and bottom. I'm going to multiply each term by these two multiplied together. I'm going to do times x squared x plus delta x all squared. So I'm going to multiply each term by that. So I'll write down the middle step as well. So we got x squared times this all squared over this all squared minus the same thing and then all of that divided by delta x. You have to multiply here as well. So delta x times x squared times this. Alright, so far it just looks worse, but now we can see that this bit cancels with this, and this cancels with this. So we're left with x squared minus x plus delta x all squared over. Right, what we're going to do at the bottom, we have to multiply out this bracket here. So we've got x squared delta x, and then I'm going to just do this bracket, x squared plus 2x delta x plus delta x squared. Right, it's starting to look a bit better because if you think ahead, we're going to get some things cancelling soon. So we've got x squared minus, and then in this bracket we've got the same thing that we had down here, 2x delta x plus delta x squared all over this. Let's multiply this out as well. So we get x to the power of 4 delta x plus 2x cubed delta x squared plus x squared delta x cubed. Right, so luckily we got x squared and x squared, they cancel. So we've got negative 2x delta x minus delta x squared. And down here we got x to the power of 4 delta x plus 2x cubed delta x squared plus x squared delta x cubed. So now we can finally see that we've got delta x in each term here. So we can divide every term by delta x. we get minus 2x minus delta x over x to the power of 4, 2x cubed delta x plus x squared delta x squared. Okay, so we're now going to take the limit. Alright, I ran out of space here, so I'm going to have to rub out a bit. I'll move this up. We're going to take the limit, so dy by dx is equal to the limit as delta x tends to 0 of this expression we just had. Let's just write delta y by delta x. To take this limit here, we can think about the numerator and the denominator separately. So in the numerator, if delta x is really tiny, then negative 2x minus this tiny delta x, the tiny delta x is not going to matter much, so that's going to be minus 2x. And in the denominator, we got x to the power of 4. The thing that's going to matter least is delta x squared, but this one with the delta x is also not going to matter much, so we can ignore that one as well. And we just got x to the power of 4. So we get minus 2x over x to the power of 4, and one of the x's cancel. So we get this. So it was quite a lot of algebra, but we got there in the end. The derivative of 1 over x squared is equal to negative 2 over x cubed. Right, so that was 3 examples of differentiating from first principles. I hope that helps.